Alright, so we're going to start sketching rational functions. To sketch a rational function, you have to find a whole lot of things. And so all of these things are going to help you sketch the graph. So the first thing we need to find are holes, then all asymptotes, vertical, horizontal, and slants, if you have one, x and y intercepts, domain and range, other points that I'll show you how to find using your calculator, and then end behavior. So the first function that we have is 2x minus 1 over x. I'm going to start by finding any holes in the graph. I would find those by factoring. Since I can't factor and nothing cancels, there are going to be no holes in the graph. The second thing I need to find are vertical asymptotes. So vertical asymptotes are going to come from what makes the bottom 0. So the only number that would make the bottom 0 is 0. So x equals 0 is going to be the vertical asymptote. Third thing I need to find are the horizontal asymptotes. Those we use our Boston rules. And so the degree of the top is going to be 1. The degree of the bottom is going to be 1. And so since the degrees are the same, I just take the leading coefficients and divide them. So 2 divided by 1 would just be 2. So the horizontal asymptote is going to be at y equals 2. Since there's a horizontal asymptote, there is no slant asymptote. The fifth thing that we need to find are x and y intercepts. Fifth and sixth thing are x and y intercepts. So for the x-intercept, I'm going to let f of x, or let y be 0. So 0 equals 2x minus 1 over x. If this is over 1 and I cross multiply, I'm going to get 0 equals 2x minus 1. The same as if I set the top equal to 0. So then if I solve this, x is going to equal a positive 1/2. And so then I know my x-intercept is going to be at 1/2, comma 0. Alright, the sixth thing I'm going to find is the y-intercept. So the y-intercept, I'm going to plug 0 in for y, so this is going to be 2 times 0 minus 1 over 0. Now, since the 0 is in the bottom, that makes this undefined. And since I can't have an undefined y-intercept, there are no y-intercepts, or none. Alright, the seventh thing, or the next thing that I said we needed to find was the domain. So the domain, you're going to look at the original function. And the original function just has an x in the bottom. And so we don't want that bottom part to be 0. So the domain of the function is x cannot equal 0. Now, the eighth thing, the range, we need to find that by looking at a graph. And so we can't find the range until we graph what we know. So I'm going to go graph what I know. And then I'm going to do the ninth thing to help me finish my graph, which is find other points on the graph. And so then I'm going to go ahead and graph my vertical asymptote. That's at 0. And I'm going to represent that with a dotted line since it's not technically part of my graph. The horizontal asymptote is at y equals 2, so that's there. Now my x-intercept is going to be at 1/2, 0, so I'm going to go graph that over 1/2 up 0. So there's that. And then I don't have a y-intercept. Now, this vertical asymptote creates 2 sections to my graph. The first section is over here to the left of the asymptote, and the second is to the right. In each section, I need at least 3 points. So when I go to do the ninth thing, which is find other points on the graph, I'm going to make a little table. And I'm going to go find different points. And it doesn't really matter what points I find over here. As long as I find at least 3, I should be okay. So I'm going to find -1, -3, and -5. Or -5, -3, -1. And then over here, I've already got 1 point. So I'm just going to find 2 more. I'm going to find one at 3 and 6. And so the way that I'm going to find these other points is by using my calculator. And so I'm going to plug this original function in, and then just go to the table on my calculator. Alright, so then let's plug this in. So I've got 2x minus 1 divided by x. And so then I'm going to go to the table and find the points I was looking for. So the points I was looking for are -5, -3, and -1. I'm going to find those first. So -5 would be 2.2. And then the next one, I'm going to round that to 2.3. And then at -1, it goes to 3. Alright, when I look for 3 and 6, those points are going to be at 1.6. I'm going to round that to 1.7, and this would be 1.8. So they're about in the same place. And then I'm going to go plot those points. So at -5, it goes up to 2.2, which is going to be a little above the asymptote. At -3, it's going to be 2.3, which is a little higher than that. And then at 1, or at -1, it's going to be at 3. Now, those points have to connect. So those points are going to connect, and the way that I'm going to know how to draw the rest of the graph is because with rational functions, these graphs are always going to hug up or be real close to the asymptotes. And so instead of saying follow the yellow brick road, I say follow the asymptotes. So you're just going to follow this asymptote, and this is going to shoot up. This is going to shoot out and follow that asymptote. Over here, I'm going to go graph the rest of these points. So 3 goes to 1.7. 6 goes to 1.8, so it's close to that asymptote. These 3 are going to connect, and then it's going to follow the asymptote. So it's going to shoot down, follow the asymptote, and shoot out, follow the asymptote. And so here's our graph. Now that we've got our graph, we can go back and find the range. And so the range goes from the bottom to top. Okay, so it wants to know what the highest value and the lowest value is. And so I'm going to look at this graph and start down here. This graph shoots down to -infinity. And so as I come up, this graph is going to have all of the y values, -6, -5, -4. It's going to have all of these y values until maybe I get to this asymptote. Because once I get to this asymptote, it's leveling out. And it's not going to cross this asymptote out here. Okay, it's just going to get real close to it. If we have a graph that crosses the asymptote, we'll be able to tell from these points that we've already found up here. This one's not going to. It's just going to get really close to the asymptote. Okay, get really close to the asymptote. And so the only place that's never going to be a y value is at 2, which is at our horizontal asymptote. So I'm going to say y cannot equal 2. That's the only y value I'll never have because these graphs are not going to go through it and it's not going to touch it. And so then the 10th thing that I'm going to ask you to find is the end behavior. And that's just this. As x approaches -infinity, y or f of x approaches what? And you fill in the blank. As x approaches +infinity, f of x or y approaches what? So then as we approach -infinity out here, this graph is going down and it's getting close to what y value? F of x is basically the same thing as y. So as I go way out here on the x-axis, what's my graph doing? It's getting close to that horizontal asymptote, which is at 2. So as I go way out on the x-axis, as x approaches -infinity, f of x, or the function, is approaching 2. On the other side, as x goes out to +infinity, this graph is getting really close to the asymptote again, so it's going to approach 2 as well. So both sides are going to approach 2 as we go far out in the negative way or in the positive way. And so then that's everything we need to know to sketch our rational function. Alright, number 2. For this one, if I'm trying to find holes, I'm going to have to factor and cancel. So to factor the top, I'm just going to factor out a GCF. That's going to be x minus 1. Alright, the bottom, I'm going to try to group this. If grouping works, I can use grouping. If it doesn't work, then I'm going to use synthetic division. So I'm going to use grouping on this and see if it works. I'll know if it works if my parentheses match. So I'm going to come over here in this little box and do it. So I'm going to pull out an x squared, and that'll leave me with an x minus 2. I'm going to pull out a -1, and that'll leave me with an x minus 2. Since these two match, I can use grouping. And so when I factor out the x minus 2, I'll be left with x squared minus 1. And then I can come over here and factor that down again. So I've got my x minus 2. And then the x squared plus 1 is dots. It's difference of two squares. So then that'll be x minus 1, x plus 1. And so I'm going to go ahead and get rid of this work since I don't need it anymore. I've factored the bottom. I just need to have more room. So I'm going to go ahead and cancel out the x minus 1. So that first thing that I need to find is a hole, and I have a hole in this graph. So this is going to be a hole at 1. And to find the y-coordinate, I'm going to plug 1 into what's left over. So this is going to end up being 1 over. If I plug 1 in for x, that'll be 1 over. And then when I say 1 into these two factors, 1 minus 2 times 1 plus 1, that would be 1 minus 2 is a negative 1. 1 plus 1 is 2. So this would be a negative 2, and the negative is just going to come up and make the top negative. So I'm just going to write that as negative 1/2. Alright, the second thing I need to find is our vertical asymptotes. And so I have two vertical asymptotes in this function from the two factors that didn't cancel. And so the vertical asymptotes are going to be at x equals 2 and negative 1. Third thing I need to find are horizontal asymptotes. Horizontal asymptotes we find using the Boston rules, and so I'm going to look at this original function right here. It's easier to look at that so I can see the degrees. So the degree of the top is going to be a 2. The degree of the bottom is going to be a 3. And so the bottom is bigger. So by Boston, bottom is bigger, y equals 0. So y equals 0 is our horizontal asymptote. Alright, fourth thing I need to find is x-intercepts. Alright, so x-intercepts, I'm going to let 0 go in for y, and I'm going to set that whole function equal to 0. The bottom is just going to end up going away if I put a 0 over 1, x squared minus x. Bottom, I don't want to write all of that out. So if I cross multiply, 0 times the bottom is just going to be 0. And I'm going to go ahead and factor the top, since 1 times that top is not going to change it. And so then my x-intercepts, x would be 0 and x would be 1. Now, at 1, I've already seen that there's a hole there. So this is actually not an intercept, this is going to be a hole in the graph. So my only x-intercept is at 0, 0. Now, the fifth thing, the y-intercepts, I'm just going to plug 0 in for all of the x's. So 0 squared minus 0 is just 0. 0 cubed minus 2 times 0 squared minus 0. All of these three terms are going to be 0, and 0 plus 2 is just 2. And then 0 divided by 2 is going to be 0. So the y-intercept is going to be 0, 0. The sixth thing that I'm going to find is the domain. And to find the domain, I'm going to look at these three bottom factors. Okay, so I don't want the bottom to be 0. So all three numbers that would make these three factors 0, I have to say x cannot equal. So x cannot equal, this would be a positive 2, a positive 1, and a negative 1. So domain can't be all three of those. Now, the seventh thing is the range. So at this point, I need a graph to find the range, so I'm going to go graph what I know so far. So first thing I know is that there's a hole at 1, negative 1/2. So over 1, down 1/2, I'm going to go put an open circle. We don't want to put a closed dot there, you just want to put an open circle because there's a hole and our graph can't go there. Now the vertical asymptotes are going to be at 2, negative 1. So at negative 1 right here, I'm going to have a dotted line. At 2, I'm going to have a dotted line. And so then my horizontal asymptote is at y equals 0. So that's going to be right here along the x-axis. Now my x-intercept and y-intercept are 0, 0. So those are the same point. That's going to go right there. Now remember, I told you that a graph can cross a horizontal asymptote. Okay? And so this is one of those graphs that do cross the horizontal asymptote. So the horizontal asymptotes, remember, just tell you in behavior. Okay? So it crosses right here. And that's really all I know to graph so far. So I can see that the graph, because I've got two vertical asymptotes, it's going to divide it into 1, 2, 3 sections. And so I'm going to go plug this function in and get 3 points, or make sure I have at least 3 points in each of those sections. So let's plug this in. So I've got x squared minus x, and both bottom and top have to go in parentheses. So x squared minus x divided by x raised to the third minus 2x squared minus x plus 2 goes there. So then I'm going to go to my table, and for number 8, find my other points. Alright, so I'm going to find x and y points. And I forgot to say right up here, the reason, if we did slant asymptotes, there would be none. There's no slant asymptotes because there's a horizontal asymptote. Alright, so I'm going to pick the points that I want to find. So x and y are here, and then my 3 points that I want to find in this first section, I'm just going to say are -6, -4, and -2. Alright, now, in the center, I've already got 2 points, and from those 2 points, I know that my graph, they have to touch, the hole is lower than this point, so I can pretty much tell that this side is going to continue to go down and follow that asymptote. But I don't really know what this side to the right is going to do, so I would like to find the point at -1/2. So I'm going to put -1/2, and that'll be my other point for that middle section. And then for the third section, I'm going to find the point at 3, 4, and 6. And you could have done 3, 5, and 6. You could have done 4, 5, and 6. I just picked 3. It really doesn't matter. So then I'm going to go to my table and find those points. So -6 goes to -0.15. -4 goes to -0.22. -2 goes to -0.5. Hang on 1 second. I'm trying to. It won't move out. Go ahead. At what time?
Think about something you want to add something on it once.
Okay. Okay. Okay.
And I'll, my mom, I think she's going to buy it tonight.
Yeah, she seems to be good.
But she's not, she's flip-flops every year. She's got trouble in with
Yeah.
the kind of land, and then she has trouble in
Okay. Thank you. Alright, sorry about that interruption. I couldn't get this over to pause it, so that, sorry, if I can somehow edit this, then I'll edit this, but anyway, so I'm going to go finish finding my points here. So, -2 goes to -0.5. -1/2. Now, -1/2 is not in our table, so I'm going to go over here to my graph, and so I can see, you can check this, you can use the graph to check to make sure you're doing these right, but you really should be able to do these without a calculator. And so since -1/2 is not in my table, I'm just going to hit trace and type in -1/2. So -1/2 gives me the point at 0.4. And then 3, 4, 6, they should be in our table. So I'm going to go down to 3, 4, 6. And so that's 0.75, 0.4, and 0.2. So 0.75, 0.4, 0.2. And so I'm going to go graph all of these points. So at -6, I go down to -0.15. So that's really close to the asymptote. -4, it's down just a little bit lower. And at -2, I'm all the way down at 0.5. So these points are going to connect, and then they're going to follow the asymptote. So it's going to shoot down and out. Now, -1/2 goes up to 0.4, so that's about right there. And so these are going to connect, and then it's going to shoot up and follow the asymptote. And then at 3 it goes up to 0.75, so that's here. 4 is down to 0.4, so that's about there. And 6 is down at 0.2. So these are going to connect. And my graph is going to follow the asymptote. So here is my graph. Now the range on this one is a little bit tricky, so you've got to be real careful. The range goes from bottom to top, and so I want to somehow see what all of the possible y values are. So I'm going to start at the bottom of this function. And so if I make my way up, I see that the function is going to shoot down forever to negative infinity. The only places that I could have a problem may be at the hole. So I would say that y can't equal that y coordinate, negative 1/2, but negative 1/2 is going to be covered by this piece over here, that point that we found. So I know that there is a point that has a y coordinate at negative 1/2. So the whole, that y value is covered by that point. Okay? The only other place that we could have a problem is at this asymptote. But I can see that this middle piece crosses through that asymptote. And so it's covered by that point. So the range on this one, since the rest of the function is going to shoot up and it's going to be covering all of the y's, I'm going to go ahead and say y belongs to set of all real numbers. Or I could say y belongs to negative infinity to positive infinity. And so then the last thing I need to find on this one, which is 9 because we forgot our slant asymptote, this is going to be, wrong thing, in behavior. So as x approaches negative infinity, f of x approaches, you fill in the blank. As x approaches positive infinity, f of x approaches, fill in the blank. So this is what you're answering every time when you tell me in behavior. So as we go way out to negative infinity, what's the graph or function approaching? And that's just going to be the horizontal asymptote. So that's going to be 0 there. X approaches positive infinity is going out this way, and our graph is getting really, really close to the asymptote, which is again at 0. And we have 2 more examples, but I'm going to do those later. Some of them involve a slant asymptote. So this is part 1. And so I'll do the rest of the examples in part 2.